Conservation of momentum. Some of the most powerful concepts in science and physics are called conservation laws. This was covered in some detail in the work and energy unit of this course. Please refer back to there for more detail. But here's a summary. Conservation laws apply to closed systems. These are systems where the objects only interact with each other and nothing else. They will enable us to solve problems without worrying about the details of an event, and there will be no external forces acting on this system. That was the point of this. The objects are only interacting with each other. There's no forces coming from outside the system. In the last unit, we learned that energy is conserved. Like energy, momentum is a conserved property of nature. This means it is neither created nor destroyed. The total momentum of a closed system is always the same. The only way that you can change the momentum of a system is if you add or take momentum away by an outside force. Conservation of momentum is used to explain and predict the future motion of a system of objects. Frankly, that's a good summary for what physics does in general. As with energy, it will only be necessary to compare the system at two times, just before and then just after an event. So here we have two objects heading towards each other, one with velocity v1, the other with velocity v2. They collide, and then they move apart. They rebound. We're going to use this little asterisk sign here to show the velocity of the objects after the collision. If there are no external forces, so this will be a closed system, then the momentum before and after the collision is the same. The momentum of an object, again, let's just talk about one object, changes when it experiences an impulse. And this basically is the impulse momentum equation written a little differently, right? Because impulse is equal to final momentum minus initial momentum. So the impulse comes when you have a non-zero external force acting on the object. We will extend that for a system of objects. So here we have a system, an initial condition. We add an impulse to the entire system, and then we will get a new final momentum. If there is no external net force on the system, then F will equal 0, and therefore the impulse will equal 0. So when we have this equation for the system, where the initial momentum of the system plus the impulse is the final momentum, we get rid of the impulse, and we have the initial system momentum is equal to the final. Thus, the momentum of the system is conserved. It does not change.